Alright, these are our notes for section 7-3, day 2 on 30, 60, 90 triangles. Last class we looked at 45, 45, 90 triangles. Today we're going to still continue with special right triangles, but we're going to look at a 30, 60, 90 instead. Alright, 30, 60, 90. Those refer to, just like in a 45, 45, 90, the angles of a right triangle. Okay? And again, this is a shortcut instead of using the Pythagorean theorem. I know a lot of people like to use the Pythagorean theorem, but this is a shortcut. This will save you some time if you're only given one specific side of a triangle. Okay, so here's what that looks like. You've got 60 and 30, and then one of the angles has to be a 90-degree angle. I do want you to notice that that's the smallest angle here, smallest side, that they're across from each other. 60 is in the middle angle. Okay, so this should be the medium length side. And this is the small side over here. Okay, and then the hypotenuse, which we've already said, we said this before, the hypotenuse is always the longest side of a right triangle. So the angles correspond to the side lengths, which we've learned that before. We've said that before in class. Okay, something else to remember is that half of an equilateral triangle is a 30, 60, 90 triangle. Okay, we know all the angles in an equilateral triangle. Our big triangle here would be 60, and we draw that straight down and make a right angle, which would mean this has to be 30. Okay, so half of it would be a 30, 60, 90 triangle. We will not see an example of that in the video. You will see an example of that in class on your worksheet. So make sure you remember that. That's important to remember. Half of an equilateral is a 30, 60, 90 triangle. Alright, the big idea here. Now, this big idea is more complicated than the one for a 45, 45, 90, because in a 45, 45, 90, two of the sides were the same. In a 30, 60, 90, all three sides are different lengths. It's a scalene triangle. Okay, that's important. 30, 60, 90 is a scalene triangle. Now, what we do is we say that the side across from the 30 is the short side, and it's going to be N. Okay? Side across from 30 degrees is N, and we call it the short side. Okay? The side across from 60 that is really N root 3. Now you could put whatever variable you wanted in here. I'm using N just because that's the first thing I thought of, but sometimes you'll see X, sometimes you'll see Y, it doesn't matter. But in this case we have N root 3, okay, and we call that the long side. Okay, the last one, the side across from the 90-degree angle, its measure is 2N. And it's the hypotenuse, okay, which should be the longest of all, okay? It should be the longest in the whole triangle. So, in our triangle, we have three different side lengths. We have N root 3, and 2N. Now, depending on which side they give you, because they will only give you one of them, that dictates how you'll solve the problem. And we've got 6 examples here, 2 of each type. First type is when you're given the short side. This is the easiest. Okay, the easiest one to solve, because that would mean I give you N. So if we look at our first example here, we've got a 30, 60, 90 triangle. We know that because it's marked. It's got 30 and 60 as its degree measures. And I give you the side across from the 30. So this is our N. To figure out the X, the long side, we said that our rule was it's N root 3. Well, if N is 3, that means this is 3 root 3. And that's it. We just plug it in. If we want to find the hypotenuse, we said that it is 2N. So we would do 2 times 3, because N is 3 in this case, which is 6. And there's the long side. That's how you solve this problem. Okay? We're going to look at example 2. We're going to use the same idea. This time, though, it has a radical in it, which changes it a little bit. It's not any more difficult, but we have to multiply radicals together. Okay, so this would be n. Now, to find x, that's the long side because it's across from the 60. So it was n root 3, but in this case, n is 2 root 2. So we're going to take 2 root 2 times root 3, we multiply those together, and we get 2 root 6. Okay, there's our x, 2 root 6. To get y, that's the hypotenuse, it's 2n, so it's 2 times 2 root 2, which gives us 4 root 2. Okay, so there's our answer for y. What I want you to do on these, it's really important. Okay, they're not difficult, but it's really important to figure out which side is which. That's the hard part. And once you've done that, then you can just plug numbers in. Okay? So for both of these, make sure that you realize n is across from the 30. It's the short side. Okay? The next set, these are when you're given the hypotenuse. This is the second easiest type. Okay? The first set where you're given the short side, those are the easiest because all you got to do is plug numbers in and multiply. This is the second easiest because there's 2 steps instead of 1. We are given the hypotenuse here, which is really 2n in our triangle. So if we want to go over here to the short side, we have to divide by 2 because that's how we would get n. So we have 20 divided by 2, which is 10. There's our answer for the short side. To find x, it's 10. Now to get over to this side, to the y, we have to multiply by root 3, because it's really n root 3. So it would be 10 root 3. Okay, and there's our answer for y. It might help you to draw your arrows around the triangle. Okay, we're given the hypotenuse here, which is 2n. So we're going to draw an arrow over to the short side, because it's across from our 30. To get that, we cut it in half. We divide by 2. So 5 root 3 over 2, well, that's not going to reduce. So there's our answer, 5 root 3 over 2. To get to the other side, we have to multiply by root 3. We divided by 2. We're going to multiply by root 3. So we have 5 root 3 over 2 times root 3. And that's really root 3 over 1. The only reason I made it as a fraction is so that we have something on top and something on bottom to multiply by. Well, 5 times root 3, and root 3 is really root 9, but root 9 is really 3. So it's really 5 times 3, which is 15, over 2 times 1 is 2. So there's our answer, 15 over 2. Or if you wanted to put 7.5, that would work. This one's trickier, okay? If you start with the hypotenuse, you have to cut it in half first. That's what we mean by divide by 2 to get the short side. And then tack a root 3, multiply by root 3 to get the long side, okay? So 2 steps here. First step, if you're given the hypotenuse, cut it in half, and then multiply by root 3. The long side, these are the most difficult, okay? Because we're dividing by, we're going to follow the same steps basically we did on given the hypotenuse, but we're going to have to divide by a radical, which means we'll probably have to rationalize. Okay? Notice here that we are given the angle 60, the side across from that 60, okay? Which means we're given the long side. Now we're going to work our way to the short side, okay? If we had the short side, we would multiply by root 3 to get the long side. So here we're going to divide by root 3 to get that short leg. So we have 12 divided by root 3. We can't have that. So we got to pick our well-chosen 1. Root 3 over root 3, we get that from the denominator, and we multiply straight across. So 12 root 3 over root 3 times root 3 is really root 9, but root 9 is 3. And this will reduce. 3 goes into 12 4 times. So it's really 4 root 3. There's our short side. Now to get from the short side to the long, or to get to the hypotenuse, we multiply by 2. So now we have 4 root 3 times 2, which gives us 8 root 3. And there's our hypotenuse. Okay, this one again is more difficult because we have to take that long side, divide it by root 3 to get the short side, and then multiply by 2 to get the hypotenuse. Let's look at our next example here. This one's going to be more difficult because we have a radical in there. Okay, 60 and 30. We are given the long side, so we've got 3 root 5, and we're going to go to the short side, so we have to divide by root 3. So we're going to rationalize it, times root 3 over root 3. Multiply across the top, that gives us 3 root 15 over. Now this is similar to what we had when we divided by root 2 with the 45, 45, 90. When we're dividing by root 3, it's always just going to end up being 3. Okay? Those happen to cancel on this example, so we are left with root 15. There is our short side. Now to get to the hypotenuse, we multiply by 2. So 2 times root 15 gives us 2 root 15. There's our answer. Okay, again, this one is the most difficult because to start with, when we're given the long side, we have to divide it by root 3, and then we have to multiply by 2. Remember, use your notes when we do this worksheet. This is difficult because you've got 3 separate cases and you solve them each differently, okay? Remember, the short side is the easiest because we multiply for both of them. The hypotenuse is the second easiest, and we divide by 2, and then we multiply by root 3. And then if we've given the long side, we do the opposite of what we did for the hypotenuse. We divide by root 3 and multiply by 2. Those are your notes for section 7, 3, 30, 60, 90 triangles. Make sure that you bring any questions to class so that you can get them answered in class, because this is a difficult section because you've got so many types and so much stuff going on. So bring your questions to class.